Here's some iron. It's a powdered form known as iron filings. Iron is a type of matter known as a substance. Here's some sulfur, also a substance. If we take the iron and stir it together with the sulfur, we get a mixture. Mixtures are distinct from substances in that they can be separated by a physical process. Here we see the iron is relatively easily separated from the sulfur by use of a magnet. This is a physical process because no chemical reaction was necessary. We didn't need to break or form any chemical bonds. Let's now go back and leave the mixture of iron and sulfur as it was, and put it in a test tube and bring a Bunsen burner and heat the mixture. After several minutes, we notice some pretty dramatic changes. Colors change, some gas is produced, the iron-sulfur mixture now looks black. What's happened is the iron and sulfur have formed new bonds at the atomic level and are no longer a mixture, but now together make a new substance, iron sulfide. Once the iron sulfide is removed from the test tube, it looks like this. And one clue we have that it's no longer a mixture is the iron can no longer be separated from the sulfur by a magnet. Notice no particles jumping up to the magnet like before. Let's go back to the beginning. Matter is anything that has mass and takes up space. That may seem like it encompasses everything, but not quite. Heat is not matter. Light is not matter. If you're having the thought right now,
how could I possibly be expected to handle school on a day like this?
That thought is not matter. What is matter is iron, sulfur, iron sulfide, iron and sulfur mixed, wood, water, air, and so on. We generally break matter down into two parts. Most of what we know in our world is a mixture. As we mentioned already, mixtures can be decomposed into component parts by a physical process. This is why the iron-sulfur mixture could be separated with a magnet. Mixtures contain two or more substances. So the other main category of matter is a substance. A substance cannot be decomposed into its component parts by a physical process. That's why when we held a magnet next to the iron sulfide, it couldn't pull the iron away from the sulfur. There are two types of substances. Iron and sulfur were each examples of elements. The simplest way to know you have an element is if you're dealing with just one of the symbols on the periodic table. Here's the element iron, the element sulfur, carbon, sodium, and so on. The other type of substance is known as a compound. Compounds contain two or more elements. Iron sulfide was an example of a compound because it contained two elements, iron and sulfur. Water is a compound with hydrogen and oxygen. Sugar is a compound comprised of carbon, hydrogen, and oxygen. See if you can identify which of the following are elements and which are compounds. Stop the video now, write down your answers, and only then restart the video to check yourself after you've tried them all. Okay, iron is an element. Sulfur is an element. S8 is still just sulfur. It has 8 sulfur atoms per molecule, but it's still just sulfur. FeS, iron sulfide, is a compound because it contains two elements, iron and sulfur. CaBr2, calcium bromide, is a compound which also contains two elements, calcium and bromine. Pb is an element. Here is Pb, the element lead. Even though the symbol for lead has two letters, P and B, you know it's only an element because the second letter is lowercase. Rubidium phosphate is a compound that contains three elements, rubidium, phosphorus, and oxygen. CO, carbon monoxide, is a compound that contains carbon and oxygen. Here's carbon, here's oxygen. Now don't confuse that with cobalt. Notice the second O for cobalt is lowercase. So this last CO is the element cobalt. Let's continue our flow chart now. Just as there are two types of substances, elements and compounds, we have two types of mixtures, homogeneous and heterogeneous. Perhaps you know that the milk you drink is known as homogenized because the fat doesn't separate out. Homogenized milk has the same composition throughout. The prefix homo means same. Thus, a homogeneous mixture is where the components of the mixture are uniformly distributed, i.e. they have the same composition throughout. No matter where you look at the mixture, it looks the same. This diagram represents a homogeneous mixture of triangles and circles because no matter where you look, the pattern is the same. Notice that homogeneous does not mean that you have the same amounts of each substance. In this diagram, you can clearly see there are more circles than triangles. And as you might guess, heterogeneous mixtures are where the components of the mixture are not uniformly distributed, as demonstrated in the diagram you see here. Now, identify each of the following as an element, compound, homogeneous mixture, or heterogeneous mixture. Stop the video now and consider all of them, A through J. Remember, only restart the video after you've tried all of them. All right. Iron mixed with sulfur is a heterogeneous mixture. When mixing two or more solids, it's virtually impossible to have them mixed homogeneously. One exception to this is alloys. They are made by first melting the solids, then mixing them as liquids, then re-solidifying them. Salt dissolved in water is a homogeneous mixture. Whenever something dissolves in something else, if it's truly dissolved, then the mixture is homogeneous and is also called a solution. If some solid remains undissolved, however, then it would be heterogeneous because you'd have some solid salt settling to the bottom, but none on the top. Sodium chloride itself is a compound containing two elements, sodium and chlorine. Sodium is an element. Air is a homogeneous mixture. Now don't feel bad if you didn't get that one on the first try. You should know that air is composed of nitrogen, N2, and oxygen, O2, and smaller amounts of many other gases. Usually when two or more gases are mixed, the mixture is homogeneous. O2 is an element. O3 is also an element. It's still the element oxygen. It's the form of oxygen we call ozone, but it's still the element oxygen. FeS is a compound because it contains two elements. Finally, Fe2SO43 is also a compound. It contains three elements, iron, sulfur, and oxygen. Now on this page, the question is similar, but now you'll have to consider how particles look at the submicroscopic level. You should know that each sphere you see represents an atom, and the different colors represent atoms of different elements. So this would be an atom of one element, and this would be an atom of another element. Okay, identify each of the following as an element, compound, or mixture. Stop the video now. The first one is an element. Perhaps it could represent O2. Each of the particles, like this one and this one, represents two oxygen atoms chemically bonded to each other. Each of these two atom particles is called a molecule, by the way. This is also an element, such as helium. In this case, each particle is just an individual atom. Number C is a mixture. Recall, mixtures contain two or more substances. So this might contain the substance helium and the substance neon, both of which happen to be elements. Letter D is also a mixture of two substances. In this case, the mixture is of a compound, perhaps carbon monoxide, and an element, perhaps O2. Finally, this last one is a compound. Each molecule has the same composition, unlike the previous example in D. Well, that's it for elements, compounds, and mixtures. Thanks for listening, and see you next time.